everyone, I am Dr. Indu TK and welcome back to another exciting session in our series on Geography of India. Today, we will continue exploring the Indian climate part 2, the monsoon formation and characteristics. In our last session, we have discussed the factors influencing the climate of India. Without further ado, let's know deeper into understanding the formation and mechanism of Indian monsoon. Indian monsoon, a unique phenomena in India, is a topic that is important in the subject of Indian geography. The word monsoon has been derived from the Arabic word mosam, which means season. Originally, this word was used by Arab traders to describe a system of seasonal reverse of winds along the shores of Indian Ocean. The monsoon climate is related to the seasonal reversal of wind direction. The monsoons are seasonal wind pattern that travels from sea to land in summer and from land to sea in winter. India's climate is classified as monsoon climate. This type of climate is mostly found in Asia's south and southeast. Despite the overall consistency of the pattern, there are regional differences in the climatic condition within the country. The Indian subcontinent, Central Western Africa, Southeast Asia and few other regions all have monsoon, but the winds are highest in the Indian subcontinent. The Indian monsoon accounts for 70% of India's annual rainfall. The monsoon in India occurs through the southwest monsoon winds in summer months and northeast monsoon winds during the winter season. Monsoon in India is much awaited by the farming community in the country. India, being a majority agriculture economy, awaits a good monsoon. There are two types of Indian monsoon, southwest monsoon and northeast monsoon. The rainy season in India, also known as southwest monsoon season, that majorly dominates the region. The northeast monsoon enters India northeast region. The monsoon in India generally occurs between April and September. Therefore, we can say that India and Southeast Asia majorly depend on the summer season for its monsoon. Southwest monsoon in India. The southwest monsoon winds are responsible for bringing heavy rainfall to maximum regions in India. What initiates the southwest monsoon? The extreme heat on the Tibetan Plateau in the summer season. This leads to the formation of low pressure and permanent high pressure in south direction of the Indian Ocean. The rain caused by southwest monsoon are a result of large air currents that pass through the warm equatorial ocean, which give rise to evaporation. After crossing the equator, the southwestern winds branch out into two and move over Bay of Bengal and Arabian Sea. This happened due to the southwest monsoon winds hitting the western Ghats. The monsoon in Arabian Sea region is much stronger than that in the Bay of Bengal. High levels of evaporation from the surface of the ocean give rise to water vapor and the southwest monsoon winds. Then, filled with water vapor, gradually start cooling while rising above the land surface and moving towards the northern direction. When the air reaches its saturation point and cannot retain the moisture, it brings heavy rains. At times, there are many heavy showers of rain that even result in flood in the area. Kerala is the first Indian state to receive rainfall during the southwest monsoon. The Tamil Nadu coast generally remains dry during southwest monsoon as Tamil Nadu gets its rainfall during the winter months due to the northeastern trade winds. Next important monsoon wind is northeast monsoon. The northeast monsoon originated from the creation of high amounts of pressure over the Siberian and Tibetan plateau during the winter season. The northeastern winds are responsible for bringing rains to the southeastern coast of India. The southeastern coast of India refers to the area of Tamil Nadu coast and Simandara south coast. During the northeast monsoon, the wind blows from sea to land and monsoon winds carry the moisture created by Indian Ocean. The northeast monsoon majorly affects South India, causing rainfall in Puducherry, Karaikal, Tamil Nadu, Andhra Pradesh, Yanam, Mahi and Karnataka from the months of October to December. The 3 months mentioned above majorly result in heavy rainfall in Tamil Nadu region, which means 48% of the total rainfall in a year there. Next is the formation of Indian monsoon. The monsoon, which is simply a seasonal reversal of wind direction, is responsible for the majority of the rainfall in India and several other regions of the world. During the summer, the Thar Desert and an adjacent portion of the northern and central Indian subcontinent heat up. A low pressure zone forms over the subcontinent as a result of the fast solar heating which occurs primarily between April and May. The moisture-laden breezes from the Indian Ocean rush in to fill the vacuum. The intertropical convergence zone also swings northwards towards the subcontinent, bringing monsoon rains to the mainland in the last week of May or the first week of June. The monsoon is split into 2 sections beyond Kerala, the Arabian Sea branch and Bay of Bengal branch. By the first week of July, monsoon winds had reached virtually every part of India. The summer monsoon. The summer monsoon is known for its tremendous rain. It usually takes place between the months of April and September. These locations experience a humid environment and intense rain during the summer monsoon. The summer monsoon is critical to India and Southeast Asia. Agriculture, for example, is reliant on yearly rainfall. For the remainder of the year, the summer monsoon fills wells and aquifers. The region's economy suffers when the summer monsoon is late or poor. The summer monsoon has been referred to as India's genuine finance minister. Next is the winter monsoon. The winter monsoon in Indian Ocean, which lasts from October to April, is less well known than its wet summer counterpart. The northeast winds blow during the dry winter monsoon. These winds originate in the atmosphere about Mongolia and northern China. The winter monsoon in Southeast Asia are less strong than summer monsoon, in part because the Himalayan mountains block most of the wind and precipitation from reaching the shore. The Himalayas also keep most of the chilly air out of the region like southern India and Sri Lanka and keeping them warm all the year. Next, we will discuss about the origin of Indian monsoon. The monsoon usually comes in the first week of June near the southern tip of Indian peninsula. It then split into 2 branches, the Arabian Sea branch and Bay of Bengal branch. The time from early to mid-June, when the first batch of monsoon wind arrive on the western coast of Indian peninsula, is referred to as monsoon onset. The Arabian Sea branch arrives at Mumbai 10 days later on June 10th. By mid-June, the Arabian Sea branch of monsoon had arrived over Saurashtra, Kutch and central section of the nation. The Bay of Bengal moves quickly and arrives in Assam in the first week of June. Monsoon winds are then diverted by high mountains and flow west over the Ganga plains. The monsoon branch of Arabian Sea and Bay of Bengal meet over the northern regions of the Ganga plain. Branches of Indian monsoon. First, we will discuss about the Arabian Sea branch. It is sometimes referred to as the southwest monsoon. this monsoon trough travels around the Arabian Sea. It moves quickly and arrives in the country northwestern and northeastern region in the first week of June. The intertropical convergence zone is a low pressure zone in the equator where the trade winds converge, and it is found about 20 to 25 degree latitude in June, known as monsoon trough. As a result of this change, southern hemisphere trade winds blow from southwest to northwest and northeast. In the plains, these trade winds bring southwest monsoon. Next is Bay of Bengal branch. It is sometimes referred to as southeast monsoon. This branch of monsoon flows along Bay of Bengal. It moves quickly and arrives in the country's northeastern region in the first week of June. The heating of the continent creates low pressure which attracts the southeast trade winds from high pressure area of the sea. Monsoon wind move from high pressure area to low pressure area. A southeast monsoon from the Bay of Bengal is expected in the northern plains, and this combines the southwest trade winds. By the end of June, Delhi generally receives monsoon rains from the Bay of Bengal branch. By the first week of July, monsoon has arrived in western Uttar Pradesh, Punjab, Haryana and eastern Rajasthan. By mid-July, the monsoon had reached the Himachal Pradesh and the rest of the country. Next, we will discuss about the characteristics of Indian monsoon. The Indian monsoon is marked by a dramatic change in wind patterns with moist winds from the southwest in summer and dry winds from the northeast in winter. The southwest monsoon brings significant rainfall crucial for agriculture, filling rivers and replenishing groundwater. There is a substantial variation in monsoon onset and intensity across the different regions of India, with the western Ghats and northeastern states receiving the highest rainfall. The monsoon is driven by the temperature differential between the Indian Ocean and the Indian landmass, leading to the movement of air masses. The monsoon typically arrives in early June in Kerala and retreats from northern India by September. The Indian economy, particularly agriculture, is heavily dependent on the monsoon rains for crop production. Periods of reduced rainfall, known as the break in monsoon, can significantly impact water availability and agriculture productivity. Events like El Nino and La Nina can alter the monsoon pattern and intensity, causing either droughts or excessive rainfall. Next, we will discuss the factors affecting Indian monsoon. The Indian monsoon system is a complex meteorological phenomena influenced by various geographical factors including topography, latitude, oceanic condition, seasonal shift, land-sea temperature contrast and regional features, which significantly shape the origin and the development of Indian monsoon. Ongoing research over the last 30 to 50 years has identified many factors that affect the Indian summer monsoon. These range from long-term, large-scale global effects such as the El Nino, La Nina, Indian Ocean Dipole and more to more short-term and local effects such as dust clouds and even patterns of irrigation. Next one is the Coriolis force. The Coriolis force is a fictitious force that exists only due to the spinning action of Earth. This force is also responsible for the rotational motion observed in tropical cyclones. As a result, the monsoon winds are diverted eastwards and now blow from southwest to northeast. Because the rotating motion of the earth is constant, the Coriolis force is experienced by a particular parcel of air with specific velocity at certain latitude is likewise constant. The third important factor is mascarene high. The mascarene high is regarded as the driving force behind the southwest monsoon winds in the Indian subcontinent. This high pressure area often forms by mid-April and its strength is an essential element in determining the severity of the monsoon in India. A stronger high pressure will result in greater winds or a stronger monsoon current. If the development of mascarene high is delayed, it is possible that the onset of monsoon in India may be delayed as well. Next is the Indian summer. During summer, the winds move from places of high pressure to the areas of low pressure. The Himalayan range plays an important role in summer heating by preventing cold air from north from entering and allowing warmth to occur. During this season, the country of India becomes extremely hot. The temperature in the ocean surrounding the nation are also rising. We notice a gradient between air pressure over the sea and that over India as a result of the various heating rates and capacities of air over the sea and that over the land. The air pressure over India is lower than the air pressure over the southern Arabian Sea and Bay of Bengal. The monsoon winds are drawn in by this method. The next one is the Indian Ocean Dipole. Indian Ocean Dipole is a climate phenomena characterized by differences in sea surface temperature between the western and the eastern part of Indian Ocean. N.H. Saji of Japan University of Aizu and colleagues have found an ENSO-like phenomena in Indian Ocean in 1999 and discovered three phases of Indian Ocean Dipole, that is, the positive, negative and neutral positive IOD phase. During the positive phase, the western Indian Ocean becomes warmer than the eastern Indian Ocean. This temperature difference results in enhanced rainfall over the Indian subcontinent and East Africa, while Indonesia and Australia may experience droughts. Next is negative Indian Ocean Dipole phase. In the negative phase, the eastern Indian Ocean is warmer than the western part. This leads to reduced rainfall over the Indian subcontinent and East Africa with the increased precipitation over Indonesia and Australia. The next one is neutral Indian Ocean Dipole phase. When there is no significant temperature difference between the eastern and the western Indian Ocean, the Indian Ocean Dipole is in a neutral phase. During this phase, the Indian monsoon follows its usual pattern without significant influence from the Indian Ocean Dipole. It has been found that during the positive Indian Ocean Dipole phase, the Indian summer monsoon rainfall is significantly higher than during the negative Indian Ocean Dipole period. The next important factor is El Nino. El Nino is a climatic phenomena characterized by warming of sea surface temperature in central and eastern Pacific Ocean that occurs irregularly every 2 to 7 years. El Nino is a Spanish term that means the kid and it relates to the infant Christ as the stream begins to flow during Christmas season. El Nino often leads to a weaker monsoon in India. Reduced moisture and weakened monsoon winds result in less rainfall during monsoon season. The decrease in rainfall can cause widespread droughts. Agriculture output is significantly affected, leading to crop failures and water shortages. States depends on monsoon rains for agriculture and drinking water suffer the most. El Nino can lead to higher temperature across India, increased frequency and intensity of heat waves. High temperature can further exacerbate water scarcity and impact human health. El Nino can delay the arrival of the monsoon in India. Late onset affects the sowing of crops, disrupting the agriculture calendar. Some regions might receive below normal rainfall while others may experience unexpected heavy rains. Coastal regions and northeastern India may see more variability in precipitation pattern. Next important factor is Intertropical Convergence Zone or ITCZ. In equatorial latitudes, the Intertropical Convergence Zone is a large trough of low pressure. This is where the trade winds from the northeast and southeast meet. This convergence zone is roughly parallel to the equator, although it travels north and south with the apparent movement of the sun. The strength and location of this high pressure system have an impact on Indian monsoon. Next is tropical easterly jet stream. The tropical easterly jet stream is critical in kicking off the southwest monsoon. This jet falls over Indian Ocean around Madagascar and deepens its high pressure cell, causing a southwest monsoon to form. When the summer temperature of the air over Tibet remains high for an extended period of time, it aids in the development of easterly jet, resulting in heavy rainfall in India. If the snow on the Tibetan plateau does not melt, the easterly jet stream does not form. This has a negative impact on the incidence of rainfall in India. As a result, every year with heavy and widespread snow in Tibet will be followed by a year with a weak monsoon and less rainfall. Next, we will see the mechanism of Indian monsoon. The onset of monsoon. In April and May, when the sun shines vertically over the Tropic of Cancer, the huge continent to the north of Indian Ocean gets exceedingly hot. This causes an intense low pressure system to build in the northwestern section of the subcontinent. Because the pressure in the Indian Ocean to the south of the landmass is high due to the slow heating of water, the low pressure cell attracts the southeast trade over the equator. These factors help the intertropical convergence zone to shift northward. The southwest monsoon can be considered as a continuation of southeast trade deflected towards the Indian subcontinent after crossing the equator. These winds cross the equator between 40° east and 60° east longitudes. The southwest monsoon arrives on the Kerala coast on June 1st and sweeps fast through Mumbai and Kolkata from June 10th to June 13th. By mid-July, the southwest monsoon has engulfed the whole subcontinent. Next, the southwest monsoon season. The rainy season is from June to September. The low pressure condition in the northwestern plains have gotten even more extreme as a result of quick rise in temperature in May. By early June, they are strong enough to attract southern hemisphere trade winds from the Indian Ocean. These southeast trade winds traverse the equator, entering the Bay of Bengal and the Arabian Sea before becoming entangled in the air circulation over India. As they move through the equatorial warm currents, they bring lot of moisture with them. After passing through the equator, they head southwest. This is what the southwest monsoon are called. Next, the burst of southwest monsoon. During the southwest monsoon season, the rain begins suddenly. The first rain has a substantial cooling effect on the temperature. The term monsoon break or monsoon burst refer to the abrupt onset of moisture-laden winds accompanied by strong thunder and lightning. The monsoon may come in the first week of June in the coastal parts of Kerala, Karnataka, Goa and Maharashtra, and in the first week of July in the interior. The daily temperature drops by 5 degrees Celsius to 8 degrees Celsius between mid-June and mid-July. As these winds approach the land, the relief and the thermal low pressure over the northwest India change their southwesterly course. Next is northeast monsoon. The northeast monsoon makes its way into India from the northeast. With this type of monsoon, the wind blows from sea to land. The monsoon wind transports moisture from the Indian Ocean. From October through December, the northeast monsoon is limited to South India, bringing rain to Tamil Nadu, Puducherry, Karaikal, Yanam, Andhra Pradesh, Kerala, Mahi and South Interior Karnataka. The related rainfall, often known as the winter monsoon, is caused by low pressure system, depressions and cyclone. This is Tamil Nadu's main rainy season with 48% of the state's annual rainfall falling during these 3 months. Next is season of retreating monsoon. Monsoons are known to disappear between October and November. The southwest monsoon weakens around the end of September as the Ganga Plain low pressure trough begins to travel southward in the reaction to the sun's southward march. The monsoon has left western Rajasthan by the first week of September. It will have passed across Rajasthan, Gujarat, western Ganga Plain and the central highlands by the end of the month. Next, we will see the effects of Indian monsoon. First, we will discuss about the positive effects. Agriculture provides a living for around 64% of the population in India and agriculture is dependent on monsoon. India's agriculture success is heavily reliant on timely and evenly distributed rainfall. Agriculture suffers if it falls, especially in areas where irrigation systems have not been established. Regional differences in monsoon climate aid in the cultivation of a variety of crops. In India, regional monsoon variance is expressed in a wide range of food, clothing and housing styles. Monsoon rain serves to replenish dams and reservoirs which are then utilized to generate hydroelectric power. Winter rains from the temperate cyclones in North India are extremely beneficial to rabi crops. Next, we will discuss about the negative effects. Every year, the variability of rainfall causes droughts or floods in various sections of the nation. Soil erosion is an issue across huge parts of India as a result of a sudden monsoon burst. Sudden rainfall causes landslide in steep location, causing damage to natural and physical infrastructure and interrupting human life economically and socially. Next, we will discuss about the importance of monsoon in India. India is an agriculture economy that holds a lot of importance to rainfall. Monsoon in India is a boon that directly affects not only the health and wellness of the citizen of the country, but also the GDP of the economy. The importance of monsoon in India cannot be denied. Let us look few points about how monsoon in India is an important phenomenon. Monsoon in India is much awaited as it totally affects the growth of our necessary crops and vegetables. India utilizes a large chunk of its land for agricultural activity as compared to any other country in the world. Fewer rainfall result in unnecessary wastage of the grown crops. A bad monsoon in India results in decreased income and affects the livelihood of many people as a major amount of them work in agriculture field. A good monsoon in India can result in increased amount of hydroelectric power generation which accounts for at least 25% of India's electricity generation. In conclusion, the Indian climate is shaped by various factors from latitude and altitude to ocean currents and wind patterns. El Nino in particular plays a significant role in influencing Indian monsoon, often leading to weaker monsoon rains and potential drought conditions. Understanding these factors help us better predict and prepare for the climatic challenges that impact agriculture, water resources and the economy. Thank you for joining me today, and I look forward to our next session where we will delve deeper into the diverse and dynamic geography of India. Have a great day.